Okay, the first part of the second half is we have some milliliters of a molarity NaCl, and that's added to some milliliters of a different molarity of the PbNO3. So the first thing that we know happens when we put these two things in the beaker is it gets diluted. So I like to use the M1V1 equation, 60 times 0.04 equals, that's the volume times the molarity, equals the new molarity we don't know times the new volume, which is 120. You could change these to liters if you wanted to, but your molarity of the Cl is going to be 0.020 molar. That's the NaCl, but because they give us the KSPs for PbCl and AgCl, we can ignore the Na. We know Na is always soluble, so it doesn't really affect this equilibrium. And we do the same thing to find the molarity of the lead nitrate. So the molarity of the lead nitrate is 0.015 molar. And we also don't care about the nitrate. The relevant ions are the Cl and the Pb. So it says, will a precipitate form? Well, we have to check to see how much product of ion is in there. So we do the Q equals the Pb's concentration times the Cl's concentration squared, because that's what the expression is. It has to be squared. And we have the Pb, which is 0.015, and we have the Cl, which is 0.02, and it's squared. So the Q here is equal to 6.0 times 10 to the negative 6, and that is less than the K. Sorry. So no precipitate forms. Okay, I also want to mention, notice that there is a K here, and in the previous part we had to calculate the K. It's different because these were at different temperatures. The first part was at 10 degrees and this one was at 25. And remember that we learned the only thing that affects K is the temperature. I'm going to do a third clip for the next portion.